This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 121, a quick look at simulating power electronics in Ansys, along with news and events from the world of Ansys. Greetings to all. I'm your host for these podcasts, Eric Miller, and I want to thank all of you for listening once again. Here we are in August. It's been a busy summer so far in the world of Ansys and here at PADT. And as mentioned in the last episode, a hot summer for us here in Tempe, Arizona. After an unseasonably cool June, we had 31 days over 110 degrees Fahrenheit, which is 43.3 Celsius. We live in the desert and it's hot here, but 31 days over 110, that's a lot. It's only cooled down since then to like 108 or 109 so far in August, but we did have a rainstorm blow through this morning, so maybe the end is in sight. So if we seem a little grumpy, when you talk to those of us here in Phoenix, that's why. We have added a few people to our Ansys team here at PADT since the last couple months, and you get to meet one of them in today's podcast. But I did want to mention that we still have 3 openings for our Ansys-related teams. The first one is what we call a business development representative. So if you are just getting started in sales or you want to get started in sales, this is a great job to kind of get acquainted with the whole process and work your way into an account manager position. We are also looking to hire on the other end of the spectrum an enterprise account manager. So this is an experienced salesperson who works with major accounts, builds relationships, gets to know everybody there, kind of helps them get the most out of their Ansys investment. And that's a really rewarding and exciting job. If you're interested in that and have experience in that area, do apply. And on the technical side, we've only got one position open. We filled all of our technical positions except this one, and it is for a model-based systems engineer. So if you know someone or you are someone who is a model-based systems engineer, check that out. Also mention one related position. It's not specific to the Ansys team. It's to the whole sales department, and it's the demand generation marketing specialist position. So this is a marketing person who's basically going to do social and email and all sorts of demand generation type stuff, supporting both the 3D printing and simulation teams. So again, if you know someone who's interested, or if you're interested yourself on any of those positions, head on over to www.padtinc.com and go to the About part of the menu, and then click on Careers to learn more about what's going on in those positions. And hopefully you know somebody that's interested and they can join. So today, for our interview, we're going to talk about an area I actually know very little about, which is power electronics. I know it's this box or this card that I've had the design around, or most often come up with some way to cool, but rarely I've been involved in what actually goes on inside that box or on that card. And it's a very important part of any system with any kind of electronics, of course. And because it's so important, because it's just an integral part of designing anything today, especially with miniaturization and different power requirements, electrification, it's a huge deal. So Ansys has a multitude of tools to help users simulate and optimize their applications in this area. So let's dig in here and learn more from 2 of PADT's actual experts on the topic. Well, we want to welcome everybody to our discussion today about power electronics and Ansys. And I am joined by 2 of our experts here in PADT's support team, Alex Moody and Tyler Buntin. How are you guys doing?
Doing well.
I really want to thank you for joining me today on this one. And you'll hear this a lot, listeners, as well as you 2 guys. This is not my area of expertise. And so I'm coming into this wanting to learn as much as those of us who are listening to the podcast as well. But let's get started by understanding who you guys are. So Alex, your name starts with an A, so I'll ask you first. Can you just let us know, about yourself, what you do at PADT, and that kind of thing?
Sure. My name is Alex Moody. I'm an application engineer at PADT, and I cover kind of the high frequency electronics part of the Ansys portfolio. My background is in electrical engineering, and I worked in the defense and the commercial industries, wireless industries, doing antenna design, filter design, sort of high frequency microwave stuff. And at PADT, I support products that do those kind of tasks.
Excellent. Very good. And Tyler?
Yeah, so I'm Tyler Buntin. My expertise is more in the low frequency electromagnetics space, so the opposite side of the spectrum from Alex. My background is mostly in grad school up to this point.
Great.
So I got my PhD in electrical engineering, specifically in pulsed power.
Mhm.
So we did a lot of power electronic stuff there. So that's where my experience comes from. And then at PADT, I support the low frequency tools.
And you're new to the PAT team, and this is your first podcast, right?
Yes, it is. I've been here for about 4 months now.
Great. Well, welcome aboard. We're really glad to have you. And rounding out our capability in the electrical space is really important because more and more of our customers are getting into this area, and that's why we're talking about power electronics today, right? I think what little I do know about it is it's everywhere. Everything needs power, and why don't we start with kind of an explanation of what you guys think, how we define in the simulation world, really, what power electronics is.
Sure. So power electronics convert power into a usable form for your
Hmm.
electronics device.
Hmm.
And so, like you said, they're using almost all forms of electronics. So everything from your cell phone to your television to like a charger that charges an electric vehicle.
Hmm.
And basically, they convert different forms of power to something that's usable for your device.
Okay. So it would be like going from AC to DC or DC to AC. It would be changing the voltage. It'd be changing the amperage, maybe creating all sorts of different things like that, right?
Exactly. All the above.
Okay. Okay. Very cool. And of course, I'm visualizing in my head when in, I think, high school, we wrapped copper around a nail with different number of windings on each end and made, I guess that's power electronics, right? Got to change the voltage, right?
Yep.
Cool. So does this also include on, say, a printed circuit board where I'm dealing with relatively high voltage, or is that something a little bit different?
Oh, it can be. I mean, high
Mhm.
voltages are definitely involved.
Okay.
High voltages, high currents, relatively high powers in general.
Okay. Cool. Very good. Very good. So, in the world of simulation, what kind of modeling do people usually do in this space? And how and why, I guess, is it they do that kind of thing?
Well, there's a few different physics, I guess, you'd want to be
Mhm.
simulating when it comes to
Right.
power electronics. So one type of physics, or is the kind of the electronics, the electrical noise generated by these circuits.
Okay.
So electromagnetic interference is a concern that a lot of designers would have when it comes to their power electronics design. So you're handling relatively large currents. You have these switches, these semiconductors are switching
Mhm.
on and off very rapidly. So
Okay.
those time varying currents are going to generate electromagnetic waves.
Mhm.
And that electromagnetic waves can, they can radiate, and so
Mhm.
they can interfere with other devices, or even within the device, they can create what are called conducted emissions and cause problems within your device. So that's undesirable behavior. And so there are many different standards involved in terms of how much interference you're allowed to
Okay.
generate with your device.
Mhm.
And so in electronics desktop, we have a few different tools that can be
Right.
used to help predict this electromagnetic interference. Because, of course, if your device doesn't meet these standards, it's not a successful design. You can't sell it. And so you would want to know that before you get to the test chamber and fail a test. You want to predict that as early as possible.
Okay.
So in electronics desktop, we have a circuit solver that has a library of various EMI, EMC tools or circuit blocks. And so, as one example, the library has multiple, or called LISNs. It stands for
Mm.
Line Impedance Stabilization Network.
Ooh,
And
cool.
what that is, it's basically just a low pass filter that isolates
Mhm.
your device from the rest of the measurement setup. And if you were to actually perform a real EMI test in a chamber, or pay someone to do that for you, you would actually have a physical device called a LISN that would be there on that table.
Okay.
But you can use this virtual LISN block and stick it into a circuit schematic, along with a simulation that you've run in a tool like SI-Wave or HFSS or Maxwell or Q3D or any of our other electronics tools. And you can bring it in and do a virtual like conducted emissions test or a virtual radiated emissions test. And there's actually workflows where you could say simulate your PCB in a tool like SI-Wave, and then you can bring that design into a circuit schematic with a LISN and actually have your MOSFET switches driven by a voltage waveform, a switching waveform.
Mhm.
And you can look at the conducted emissions on the plot and put the limit lines and see the spectrum and see, is your device passing the conducted emissions test? And even cooler, you can then push those excitations back to SI-Wave and then solve the near fields and the far fields in SI-Wave and get the the intensity of the E field in the vicinity of your device, maybe a 1 meter offset, it depends on the standard, and see is the maximum E field within the standard's limits. So you can again
Gotcha.
plot a limit line and say, okay, am I going to fail the radiated emissions as well? So this is something again that you can catch designs early in the design phase, or sorry, problems early in the design phase rather than waiting until you've built a prototype and then taking it to the chamber and finding out, oops, we've got a
Yeah.
problem.
Right. Or in the field. Yeah.
Or in the field.
Yeah. In fact, we ran into that. We should probably contact this supplier. So on the consulting side of the business, we were working with a medical device and the power supply started to fail in the field. And it turns out that from what you described was the problem. There was some sort of a noise in it that they changed a component because of supply chain problems, and that the filters weren't catching that noise, and it was causing these power surges and causing interference and causing the power supply to fail. Yeah, if they would have modeled that change in that component, they probably could have predicted that and avoided a lot of warranty cost. Yeah.
Absolutely. Yeah.
Yeah. That's really cool. Tyler, any comments about on the low frequency side, how you simulate power?
Yeah. So the big challenge that exists that you tend to run into on the low frequency side would be the like thermal reliability of the component. So especially as we're getting to these higher switching frequencies and higher voltages and higher currents, more of that energy is going to get dissipated as heat.
Right.
So stuff's going to get hot, and we have tools using Ice Pack, which can two-way iteratively couple with any of the electronics tools.
Great.
So you can you run your electronic simulation. It sends the electromagnetic loss data to the thermal solver. It solves it with that thermal, and then throws that new temperature back to the electronic solver and says, hey, this is how hot it's going to get. So now see what the electromagnetics look like when it's at this temperature.
Right.
And as we get to more powerful devices, these thermal loads are going to become more problematic. So it's good to be able to predict and see how hot things are going to get, so that way you can do some adequate cooling. So put a bigger heat sink, or add some active cooling, some fans or liquid cooling or something like that. Knowing that you're going to have that problem before you, again, like Alex was saying, before you get to the test chamber, before you get to the test bed is good, because then you're not wasting money burning components up.
Yeah, we want to push that test to be verification instead of troubleshooting. Yes.
Exactly.
Yeah. Very cool. Yeah. So, okay, get my head around it. And you guys have mentioned a couple of the tools that we use in the suite. So, Ice Pack. I assume Maxwell is one of those tools as well that we use to generate those fields. Is that right?
Yes. So Maxwell will is what we'd use as the electromagnetic energy source, and then that information would be passed on to Ice Pack for the same model, and then they can talk back and forth a few times and figure out what the true response is going to look like.
And then on the other side, it's HFSS and SI Wave and the circuit tool. Anything else?
There's also Sherlock. So as Tyler mentioned, Maxwell and Ice Pack, they'll give you perhaps a snapshot in time of the peak temperatures. Like, is your solder going to melt? Is how hot it's going to get? But you may also want to know over time, what is the effect of the fatigue on your solder joints, or on your plated through holes, or on the structure of your printed circuit board itself? Is it going to cause reliability issues? Is your product going to eventually fail? How long is it predicted to last in terms of its operating lifetime? And so a tool like Sherlock can actually predict the stresses and strains and what that effect will be on your PCB as a platform for electronics over time. And so if there are issues with solder fatigue or plated through holes cracking and separating and breaking your electrical conductivity, you can try to catch these issues and see it in like the lifetime prediction early in the design cycle, before you're actually having RMAs from your customers and having to send them refunds or replacements. And so you can go ahead and check that with a tool like Sherlock. So it's another way to predict if you're going to have problems in the future.
Cool. Yeah, and so a big takeaway for me on this is for those who are listening who may not be responsible for those components, but maybe responsible for the packaging of those components, to realize that this all kind of works together, and you can get accurate loads instead of guessing a heat generation to do your thermal management or your stress, your vibration, or things like that. So I think that's really important. And with electronics desktop, these are getting to be more accessible as well. It's not a whole bunch of different. These all work under electronic desktop, right? All these tools.
The majority of them do.
Yeah, yeah. That makes it a lot easier to do stuff. Good, 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 good. So the other thing we wanted to talk about today is new releases, right? So anything, and it doesn't have to actually be in the most recent release, but any really cool capabilities that get you guys excited in any of these tools that the listeners should know about.
Yeah, so actually, in the most recent release, there's actually a big new co-simulation between Maxwell and Fluent, the CFD solver.
Great, great.
That you can do a co-simulation to predict electrical arcing.
Ooh.
So Maxwell can create the Lorentz force density and the conductivity of an area between two charge plates that are, close to each other. And then if there's enough energy there to generate an arc, you can then take that into Fluent, and Fluent will predict the arc's path and see how it's going to diffuse through the rest of the system. So you can see where that arc is going to connect, and what problems you're going to run into there. So that's a new capability. Was actually just released in 23 R2.
Wow, I did not realize it did that. That was one of those things that people asked for 10, 15 years ago. We're like, no. That's fantastic that it's available.
Yeah, it's there now.
Cool.
You can do it.
That's so cool. All right, cool.
And I would just give one that I thought was pretty cool for HFSS. Mesh Fusion has existed in HFSS for a few releases now.
Yeah.
But with the latest release, Mesh Fusion has been fully parallelized. So let's say that you have a printed circuit board assembly. It has lots of components and connectors on it. You can represent those components and connectors as 3D components, and represent the board itself as a layout component. And all of those different domains can be meshed in parallel, independent from each other during the adaptive meshing process. Eventually it actually lets you split this big problem into a bunch of independent domains that can all be solved in parallel. And that wasn't possible in previous releases. And so this should be a big speed up. And again, if you're doing printed circuit boards and you have lots of connectors and components, this is really the perfect problem for Mesh Fusion.
Yeah, that's really good news. And we talked about Mesh Fusion in previous podcasts. So if you want to know more about it, go back to those, or just reach out, and if you're not using it, you should be. It's kind of a game changer in a lot of ways. And now that it's parallel, even more so. That's fantastic. Yeah. Anything else out there worth noting?
That was the big one for the high frequency electronics.
Okay.
The arc simulation was the big one for the low.
Yeah. Cool. Well, excellent. Been very informative for me. I got my head around this a little bit more and understand a little bit more, and definitely something that we need to continue to use in our consulting business, as well as our customers using it, because we do spend a lot of time tracing down power problems. It is an issue when we're building hardware for other people. So it's good to use those tools in our own practice as well. I really appreciate your guys' time, and people can definitely check out webinars on these topics, as well as just reach out directly to us, and we can help answer any questions you might have or point you to the right person that can. So I want to thank you guys for your time, and have a great rest of the week. Or I guess it's Friday we're recording this, the rest of today, and a great weekend.
That's right. Happy Friday.
Yep. Thank you very much, Eric.
All right. You guys enjoy. Thank you.
Thank you.
Thanks. Bye-bye.
Bye. So once again, I learned a ton. It really is convenient having people like Alex and Tyler available to answer my silly questions. So I think I have a much better feel for what's going on in that area. So if you have any questions, or you're interested in learning more or using some of the tools we talked about, reach out to PADT or wherever you get your Ansys from. And, let's all work together, start getting better power performance through Ansys simulation. For this episode's commercial, I'm going to switch gears a bit and talk about startups. It's not something I talk about a lot on this podcast because startups, but what people who know me well know, startups are a passion of mine. PADT does angel investing, and I also officially mentor startups through the Arizona Commerce Authority and through the Clean Tech Open. I'm also available all the time for unofficial discussions, and what I really specialize in is helping startups, regardless of the phase, that have technical founders and help them understand how to do this stuff, this non-technical stuff, and also how to communicate better as a technical founder to both investors and other parts of the business world. And I really enjoy that part of my free time. I do it outside of PADT, and it's a lot of fun. But that's what I'm not here to talk about. What I'm here to talk about is a way that PADT does support the startup world, and that's through the Ansys Startup Program. So two of our fastest growing customers right now are Rivian Automotive and Ursa Major, the rocket company, right? The rocket engine company. And both started with PADT as part of the Ansys Startup Program when they were small. The program gives early stage companies access to the full suite of Ansys products with no limitations. These are not dumbed down versions of the software. They're whole packages of, say, mechanical or fluids or electronics. And it's at a price that you can afford. So we basically work with you on where that price point needs to be. And if you join the startup program through PADT, you get some added benefits. One is you get a technical support team that is outstanding. If you listen to the podcast, you know that. But you also get access to people like me that can help you with other things and kind of navigate your way around the whole startup world. So if you're in a startup, or know of someone who is in a startup and they are in Texas, New Mexico, Colorado, Utah, Nevada, California, and of course, Arizona, our territory for selling Ansys, do reach out to us. We'd love to talk to you. Let's find the right package for you so that you can drive your product innovation and virtual prototyping with the best simulation tools available. And I'll say two things before we finish this commercial. One is when I'm mentoring companies, especially in the clean tech space, they often get stuck because they don't have the capital to build demonstration hardware, right? But they can use simulation to do that, right? So they don't have to actually build the hardware. They can use simulation to prove out, optimize, and design their product. So that's a really important, and that's not just the clean tech space. That's any kind of hardware out there. So do think of virtual prototyping as a way to do your minimum viable product, not just having to build things. The other thing is, yes, it is a violation of the license agreement for you to be using a university seat or the seat from your day job. So stop it. And you may be doing that, and I understand it because you think it's going to be too expensive, that you can't afford Ansys. So you're going to use the university seat or the day job seat. It's actually very affordable. So reach out, let's talk, and let's get you up and running in the Ansys Startup Program. So if you're not a startup, let your friends who are know about it. So let's take a look at Ansys stock. Let's talk the whole financial thing because they did their Q2 numbers. So when we last talked a month ago, Ansys stock was at $326 a share, ANSS at $326. That's the beginning of July. In mid-July, it made all the way up to $351, and then it went back down to $299. So that's I'm recording this on August 8th, which is Tuesday. I looked at around 8:30, and it was at $299. So that's up 25% for the year and 6% over the past 12 months, and certainly much better than the low of 194 we saw in October of last year. So the stock is doing well. It's coming up. They did release their Q2 numbers, and the stock usually goes down after they release the numbers for some reason. If you listen regularly, I still don't get how the stock market works. I thought the numbers looked pretty good, but whatever. So let's look at those. Revenue was just under $500 million at $497 million for the quarter. That's a 5% increase over the same quarter last year. Net income is down though a bit. That's the profit is down to $70 million, and that's a 30% drop in the profit margin, and drops the profit margin down to 19.3%. That's a 19.3% drop. No. Take that back. That is a profit margin of 19.3%. The first half of the year saw $1 billion and $6 million in revenue, which is a 12% increase. But income was flat for the first half at $170 million for a profit margin of 22%. So that's the first 6 months of the year. So a number that we've talked about before and that they're really stressing more and more with every one of these financial releases is something called the annual contract value. So, when you book a multi-year deal, you may say, oh, well, I'm going to account for this in kind of weird, strange ways. And the annual contract value basically is, well, how much money do they expect in the calendar year from this sale? So anyway, that's a really good number to look at. It really tells you how they're doing. And that was at 488.3 for the Q2. And that was up 6% from last year Q2. And then the first half of the year was 888 million. And that was up 10% from the first half of 2022. So revenue was up. What did happen is they spent more money so far this year. Cash is down from 615 million to 478 million. And if you dig into the P&L, and that's why the profit is down. If you look in the P&L, basically the expenses are up Q2 over last year by about $50 million. And they basically spend it on sales, general admin, and 17 million of that was an increase in R&D spend, which we always like to see. So you can dig into these numbers. You can draw your own conclusions, none of which probably are correct, but we can play the guessing game. But you can go to investors.ansys.com and they also have a link to the streaming of the investor meeting where they talk about these numbers and experts ask questions and the executive team answers. And I like to listen to them. There's a link there for it. And you get to know the executive team a little bit as well. So it's kind of a cool way to do that. So not bad numbers considering the economic uncertainty in the world today. They're actually pretty good numbers. So we hope to see them improve as the year goes on. Let's move on to Ansys news. Well, it's kind of unusual. Ansys won 3 awards since we last talked in the beginning of July. And they're kind of cool. Number one was the first award that I'll talk about is they were number 27 of the top 100 of most loved workplaces. So, people like to work, and I can attest this is not marketing hype. I know people that work there. They do like working there. So they won an award for that. Also, in a recent podcast, we talked about this series of videos that they've done called Earth Rescue about using simulation to help with global climate change and carbon and things like that. And they actually won something called a Telly Award. They won 8 Telly Awards in the category for non-broadcast online video content for the Earth Rescue series. And like I said, we just talked about that. And I'm not saying that they won the award because it was on our podcast. Probably, actually, no, it had nothing to do with it. Just kidding. But this is outside confirmation. The series is really well done. I enjoyed it. I've recommended it to my friends who kind of wonder what I do all day. And so check it out. If you haven't watched the series, it's called Earth Rescue. Do check it out. It's now the award-winning series, Earth Rescue. The third award is kind of cool. It's called Prestigious Women of Color STEM Award. And they recognize not just one, not just 2, but 3 Ansys employees. I unfortunately don't know any of them. Ansys has become so big now, I don't know everybody anymore. But congratulations to Soma Chakrabarti, Edotola Wahab, and Karna Twan. And sorry for butchering your names, to receive awards during the Women of Color STEM conference. So that's really great to see that recognition. And it is really important to recognize the people that are pioneering that and getting more women and more people of color into the whole world of STEM. So another bit of news is, AI is in the news, ChatGPT is in the news, and Ansys is leveraging that, right? So they looked at where they could apply this technology, and the obvious place was to use this large language model tool set and pointed it at the years, maybe decades of tech support questions they've answered and create a virtual assistant, which they're working on it right now, that uses that huge amount of data to help answer your questions. So in 2024, you'll be able to go online and anytime, day or night, 24/7. And instead of asking a forum or asking a tech support engineer, you can ask a chat bot and it will use the GPT, whatever version it's at the time, maybe 5 by then, to go ahead and go through the database. So much better than search, much better than trying to guess keywords, and hopefully give you answers faster. So we're looking forward to seeing that and playing with it as well. And then you should know already, Ansys 2023 R2 was released, which is the biggest news of all these things and the most important for those of us who are users. In the world of PADT news, we got none. Nothing, we've been busy, lots of good stuff going on. Like I said, we filled a bunch of open positions, great projects going, but really nothing that we can report to you all. I do recommend, I'll make a plea for joining our newsletter. If you go to our website and subscribe to our newsletter, go to the bottom left-hand corner, you can see the pulse. You can keep up on news with PADT. Blogs. So Ansys, like I always pick 3, and Ansys had a whole bunch. It was hard to pick this time, but these are the 3 I picked. One, because we talked about it in a recent podcast episode, is called where is it there? It's called Understanding Discrete Element Method. So we talked about Ansys Rocky DEM, and we also mentioned the fact that Alstina has some DEM capability. So this is an article kind of explaining what DEM is, what discrete element modeling is, or discrete element method, I should say, is. So do check that out. Even if you're not planning on using it, I think if you know it, you might find some uses for it. The next one's really cool. I love racing, and it's called Oracle Red Bull Racing Overtakes Design Challenges with Simulation. So this is a great article about using simulation to mostly work on downforce, but some other stuff on the vehicle, and to really improve the performance of the Red Bull Racing race car. This is also introducing a new documentary series called Driven by Simulation on how simulation is driving the transformation of transportation. And so, yes, this is about the racetrack, but they also will have documentaries about cars on the road, electrification, off-road vehicles, pretty much every kind of wheeled transportation they'll go ahead and cover in that series. So I'm really looking forward to that because I love that sort of stuff. And then the last one that I'll point out is called Stacking the Deck at the Tour de France. So if you remember, one of our most popular blog posts here at PADT is the one that Nathan Huber has done. He's done 2 now, looking at the aerodynamics of ski racks and other containers on top of his Subaru. So he's an avid skier. He lives in Colorado. He works out of our Colorado office. And when he drives up to the mountains, he's always wondering about how much gas he's using, depending on how he puts his skis or where he puts his skis. The folks at Ansys who are into cycling, especially the European team, looked at it for the Tour de France and looked at, they have these cars that follow behind the cyclists, and they can put a big stack of bikes on top of it. Does that help the rider? Well, you'll have to read the article to find out. It's called Stacking the Deck at the Tour de France. And then we've had a ton of blog posts here at PADT, and I actually didn't write them down because there were so many that I'm going to go through the list really quick. The first one was just done on July 6th, was something I actually wrote called PyAnsys Tutorial, Exporting Ansys Results in 3D File Formats. So this is the beginning of a 3-part series of me learning how to use PyAnsys, but also how to create result files, 3D result files in other formats, including in the next one that'll come out in a week or so, WRML or VRML. That is a format that the Stratasys 3D printers will read, and you can do color plotting of your results. So that was one of the end goals. But there's a whole bunch of different file formats that I'll support through that. So if you need to export files, you should check it out. Or if you want to learn PyAnsys, it's yet another way to learn a little bit more about PyAnsys. The next one was put out by our local optics expert, Cynthia De La Rosa, and it's called Using the New Composite Surface in Ansys Emacs Optics Studio to Tolerance Surface Irregularity of an Off-Axis Conic Freeform. So if you're an optics person, you probably thought, that's really cool. I can finally do that in Ansys Emacs. So check it out. It is performing quite well. People do care about this, and it's a pretty cool capability that they've added. The next one was written by one of our new people here at PADT, Courtney Harris. She is one of our IT experts that helps support our Ansys user community. So a lot of you may not know this, but a lot of our tech support really focuses on IT side of things. So she wrote her first blog post on how to get to all the Ansys customer websites, because when she joined, she's like, people would go, well, go to this site and go to that site. And then there's a bunch of really good resources out there that Ansys puts up for Ansys users, but there's a lot of different sites. So she summarizes all of them, what's on them, how to get to them. It's actually a great thing. Even if you've been a long-time user, you may not know all the different websites that are available to you as a user. So she goes through all those. Then Alex Grisham is back talking about the PID controller that we've been working on for years. Matt Sutton started that project. It was an ACT plugin for Ansys Mechanical. Alex has updated it to be two controllers. One is a thermal PID controller. He's added some capabilities from some user input. And then people just wanted a thermostat. They didn't want all that other stuff. So he put in kind of a dumb thermostat. Not dumb in that it's stupid, but in that all it does is, get to a temperature, turn itself off. It's not a PID. So they're great examples of how to do Ansys mechanical extensions. And they're also two plugins or two extensions that you might find useful for your modeling if you need to have a PID controller or a thermostat. So check that article out. Alex always has some great stuff. Some good theory as well as practical how to do it. Then Cynthia's back. She's been busy. She put an article out a few days ago called Ansys Speos 2023 R2 is out. And she really liked this release. So she liked it so much, she wrote an article called Here's Why Users Should Be Excited. And she goes over the 2 or 3 features, I think 3 features that she really loves in the new release. And so again, if you're an optics person or interested in optics, do check that out. And the latest is from Christian Crowley. This is his first blog post as well. He's one of our new engineers in the mechanical area. And he wrote an article called A Crash Course in Ansys Mechanical Scripting. And what that is about is not PyAnsys and not ACT, a really quick way to automate repetitive steps or to kind of parameterize things through Python is the scripting capability in Ansys Mechanical. And I think a lot of people don't do scripting because they think it's a little bit more involved than it is. And so Christian just sat down and gives 2 examples of how to create a really simple, one is to apply your own pressure load, and the other one is to create a whole bunch of probes with their own coordinate systems. Really, really cool, very simple, very basic Python, and also how to use a record feature to help. So really liked this article. Do check that out. If you're not using scripting in Ansys Mechanical, you need to check this article out and start using it. That is it for, like I said, people have been really busy with blog posts, so I'm really happy to see that. Always useful. That is webinars. We want to talk about events and webinars. So we do have a webinar coming up on the 16th of August, which is our Fluids Update in Ansys 2023 R2. And so that is going to be in Eventbrite, like all of our webinars, so do check that out. Event-wise, we're going to be out and about quite a bit in September. The only event that we have in August is going to be the SPIE Optics and Photonics Exhibition. And Cynthia, our optics expert, is going to be at that in San Diego from August 22nd through 24th. Again, that's the SPIE Optics and Photonics Exhibition for 2023. So if you go, look for Cynthia and say hi to her. We also are going to be at the New Mexico Technology Summit, which is kind of their big tech expo. It's going to be September 7th and 8th this year in Albuquerque at the Convention Center. And I will be there 2 days. I'll be giving a talk on virtual prototyping. So basically how to use simulation to create digital twins in order to drive things like AI and virtual reality and all these wonderful things that people are doing, but they need data to feed it, and how to use simulation to do a digital twin to give them that data. And also the following Tuesday, I think it is, on the 12th, the Sandia Science and Technology Park, which is where PADT has their New Mexico office, is having its big shindig for its 25th anniversary. So PADT is proud to be a sponsor for that, and we will be there. So if you're in New Mexico, do come to the summit or do come to the Tech Park opening, and we'll have some more. Do check out the website for more webinars. We'll put those out as they can become available and scheduled. And I think that's pretty much it. We really thank you for listening once again. And don't forget to subscribe to our newsletter at www.padtinc.com/opt-in or subscribe to this podcast if you haven't already on your favorite podcasting source. Do spread the word out there about the podcast and about PADT. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 121. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.